Hi everyone. This is for anyone that missed class either Monday or Tuesday. You do have to submit this work to get credit for Monday or Tuesday's class if you're out. Here's the video that I'm going to do to go over it. So the first question is, which functions are quadratic functions? Quadratic functions are any function that can be written in the form ax squared plus bx plus c. B and c can both be 0, so they can kind of go away, or one can go away, or the other, or they both can. But you do need to have a number for a, so you need an x squared. Well, that doesn't have an x squared. This does. Yep, that's quadratic. This doesn't, so that's not quadratic. Oh, there. Perfect. Right in standard form. So there it is. Those are the two quadratics that are in, that are actually, those are the two functions that are quadratic. Next up, you have to write your own quadratic function that has a minimum point. Minimum points look like this. And what we had discovered is minimum points have a positive a value. So that value has to be positive for it to be a minimum. Vice versa, if it's going to have a maximum point, we'll have a negative a value. So because we're going to do a minimum point, we need a positive a. So actually you could have put anything, either b or d in here. So we'll just put f of x equals 2x squared plus 10. But you literally could have written anything as long as you have a positive x squared. Cool. All right, take a look at that graph there. What are the coordinates of the vertex to the parabola on the right? Well, take a look. There it is, right here. Here's your parabola. It goes, the vertex, it goes straight through there. So that coordinate is 3, -4. Question 4 says, what are the x-intercepts? They're also called zeros. We'll talk more about it later. Of the function graph to the right. So, what are the x-intercepts? They're here and here. So that would be 1, 0, and 5, 0. That's it. X-intercepts are pretty easy if you have the graph and they're on whole numbers. Okay. Next one, what is the y-intercept of a quadratic function? Well, we had discovered it's the c value of a quadratic function. And here it is, the c. Well, what's the c value here? Well, it's not 12 because this isn't actually in y equals ax squared plus bx plus c form. Now it is, and you can see that. There it is. There's our c. It's 3. So our y-intercept is 0, 3. You know it's the y-intercept because it has no x or no variable. The x, the 12, goes with the x. That's our b term. And the x squared has an a in front of it. So the c has no variable. Okay. 6. The height of the rocket, height and speed of the rocket launched after going to be modeled by the function here, where x is time in seconds after it's launched. We should now know that the rocket probably looks something like this. And we want to find the high point. So to first do that, you find the axis of symmetry, because the axis of symmetry goes through the vertex. And our b term is next to the x, and our a term is in front of x squared. So, some little math. We found that the axis of symmetry happens when x is 4. Which also means the vertex happened at 4 seconds. To find the full vertex, now we just need to know the feet, the y value of the vertex, and you do that by just simply plugging it into our function, which will calculate y for us. So, sorry, it's a little bit hard to see. But in the end, you get y equals 80. So that means it happened at 80 feet. So our vertex is 4 seconds. It reached 80 feet. Sorry, zoom that out a little better. Perfect. Okay. B says, how many seconds was the rocket in the air after launch? So it's actually 8 seconds. Because if it took 4 to go up, and it's because the parabola and symmetrical, it'll take 4 to get down. So 4 and 4 make 8. Boom, 8 seconds. Sorry about this, but number 7 kind of got mixed. But what we want to do about number 7 is to find the solutions of this equation using the zero product property. So, zoom in a little bit for you. So zero product property is a little bit new, but it's just, in the end, we're trying to find a number for x that makes this 0, because 0 times whatever this is will be 0. So this one's pretty easy. What minus 6 is 0? Well, x could be 6. Because 6 minus 6 is 0, and 0 times whatever this is 0. Okay. But we have to do it to both parentheses, or any parentheses we have. So what would make this 0, right? And kind of hard, but if you write yourself a little equation, which I've been showing you, you can find that, there we go, it's negative 12 over 5, just by making a little equation to find it. All right, number 8, which is a big discovery, which allows us to do a lot of work, is what's the same about all x-intercepts? We discovered this. What's the same about all x-intercepts? And that is the y values are 0, right? All the y values for x-intercepts are 0. That's powerful. That allows us to find them. So that's what we're going to do in the next 3 examples. I'm asking you to find the x-intercepts of each quadratic function by first factoring. So y equals x squared plus 9x. We're going to set it equal to 0. We're going to factor it using our factoring guide. There's 2 terms with a GCF of x, so I'll factor it out. I'll look at what's left. It can't be factored more. Let's use the zero product property now. What makes this parenthesis 0? Well, negative 9, so that's an x-intercept. And what makes this parenthesis 0? Students get tripped up a little bit, but it's just 0. 0, 0. All right, we'll move on to the next one. We want to find the x-intercept, so that's when y equals 0. And we're going to factor. How many terms? 3. GCF other than 1? No. It's in the form x squared plus bx plus c. So we're looking for things that multiply to c, 16, and that sum to 8. So that would be 4 and 4. 4 times 4 is 16. 4 plus 4 is 8. Because it's x squared, we can do a shortcut. X plus 4 times x plus 4. And we actually now know that we're going to have one x-intercept, because look, whatever makes this 0 will make this 0. They're the exact same. So our one x-intercept will be negative 4, 0, because negative 4 makes both 0. Okay, and the last one. Find the x-intercept, set it equal to 0, then factor. There's 2 terms here. Is there a GCF other than 1? The answer to that is yes, it's 4. So I'll factor out of 4, and you write down what's left. Oop, yep, there you go. Sorry, x squared minus 4 is left. And I guess you could figure out x here, but remember, step 3 says, look at what's left. Can it be factored more? Can this be factored more? Well, there's 2 terms, and actually it's a difference of squares. So, difference of squares can be factored as x and x. What times y is 4? Say number 2. 1 plus, 1 minus. Bring down the 4 and the 0. Okay, now, kind of easy. What makes this 0? Well, negative 2, 0. What makes this parenthesis 0? 2, 0. There we have it. Those are the x-intercepts. And this is the video for people who miss class and weren't able to attend.